Alright guys, let's continue our discussion on three-phase systems, and in this video we will look at this extremely simple problem. But what we want to establish is that inductor absorb the power and capacitor is actually the one which is produce reactive power. So the inductor is absorbing the reactive power and capacitor is producing it. And this equation, in this diagram right here in this circuit, what we have is 120 volt uh, generator. And then we got an inductor with the 4 ohms, yeah. And I think the current is not given right here, but it's very easy to find the current. It's a simple Ohm's law, which is V equal to IR, and I equal to V by R, and that would be very 120 divided by 4, and that is the 30 amps. So this 30 amps is coming from what? From this voltage right here. If you want to find out the reactive power, that again is very easy. QL equal to I times XL, and I is 30. QL is equal to, I times V. Okay, I times V. And what is I? That is 30. And what is the voltage? That is 120. And that would be 12 times 3 is 3600 var, VAR. Okay. So that is the amount of reactive power which is absorbed by this inductor right here. And you guys can see it right here. Okay. Now, an inductor, it says draw the phasor diagram. The phasor diagram is very easy. We know that an inductor, the current is lagging by 90 degrees. Yeah. So this is the current and voltage. And if you don't remember, just remember Eli. That means voltage, lead, current, and this L is stand for inductor. So that is that. Okay, let's move on to the next problem, and that would show you some very important derivation, important concept that you guys will get it. Now, if we look right here, what uh, what has happened here is that we have injected a capacitor parallel to this inductor. Okay, and that is what? That is minus 4j. The capacitor value is minus 4j, so that is xc equal to minus 4j. All right. If I want to draw the just the inductor and the voltage, so let's draw that. Okay, so the current right here is 30 amps. Okay, and this is your voltage, yeah, and here is 90 degree. Remember that the capacitor is always up. Okay, so the capacitor is right here. There will be the value of the capacitor, and this is the value of the inductor. So to find the value of the current going through this capacitor is easy, because the voltage, this is a parallel, so the voltage, this is a parallel circuit. So here is 120 and here is 120, yeah. Of course, voltage in parallel is the same, yeah. So that would be 120 divided by minus 4, that would be minus 30 amps. So that is going through what? That is going through this capacitor. Now vectorially, what do we see? These two vectors, plus 30 and minus 30, is going to be what? Is going to be 0. And that 0 is reflected right here, I equal to 0. Do you guys see that? So if we draw this, so this is 30 and this is 30. And 30 minus 30 is 0. Okay, so that's why he is saying that I equal to 0. In other words, that is very that is a an important derivation, you can say, is there, is and the reason is because this generator is not supplying any current. But where is the current coming from? This 30 amp, then that must be coming from what? That must be coming from this capacitor. And which means what? Which means that the capacitor, okay, the capacitor produce what? Reactive power. Why? Because inductor absorb reactive power. So the reactive power of this capacitor is 30 times, the voltage is 120, yeah? The voltage is 120, so 120 times 30 again is 3600, and this 3600 var is provided by the capacitor in this case. I hope that makes sense. If not, ask me in the comment questions, or when I come to the class, ask me a question there. All right.